All right, geometry, let's take a look at our flowchart. Again, we're not really using that ideal flowchart process or structure, and you can see an example of that here, okay, where we write down our information that we're given and then go to our final conclusion. But we are going to take a look at the thought process behind making a similarity statement. So remember, we're going to make a claim. Triangles are similar or not similar. We're going to evaluate our evidence. So look at the information we have on the diagram. And then we're going to justify everything with an overarching reason, which was our angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Remember, this is what we get from our diagram. Okay, so angle-angle similarity is what we use when we have two sets of congruent angles. Side-side-side similarity is what we use when we have three sets of proportional corresponding sides. And then side-angle-side similarity is what we use when we have two sets of proportional corresponding sides and the included angles congruent. And that is the setup we have for part one here. Okay, we have some congruent angles in angle C and angle R, and then I'm given information about the sides that form those two angles. So that's what I'm going to test. That's the evidence I'm going to look at to determine if my triangles are similar or not. Okay, so I'm going to compare the 8 and the 2 because those are the shortest sides in both my triangles. And then I'm going to compare the 12 and the 3 because those are the longer sides in my two triangles. Okay, so I have one set of congruent angles. Compare 8 to 2, that reduces to 4. Compare 12 to 3, that also reduces to 4. So I have a pair of sides, congruent angles, proportional sides. Proportional sides, congruent angles, proportional sides. That fits my side angle side similarity. So I can say my triangles are similar because of side angle side similarity. And then the last thing I need to determine is the order. Remember, the order matters. So in class, I started at F, went towards C, and then went to D in my first triangle. So I need to identify that same rotation, that same orientation, I should say, in the second triangle. So here I started at the end of my green segment and went toward my angle and then went up the pink side. So I'm going to start at the end of the green, move toward my angle, and then up the pink side. So F to C to D is the same as Q to R to T. So that order matters. But what if I go in a different order? So that's what I'm going to take a look at here is what if I start with C? C corresponds to R. So I could also write this triangle C and R are in the same spot. And I could go from C to D to F. So I'm going down the pink side and then the unmarked side. So R to T to Q is another way I could write this. This can change. We don't have to have the same thing here as long as the corresponding parts match up in the correct order. Okay, so F matches up to Q, F matches up to Q, C matches up to R, C matches up to R, D matches up to T, D matches up to T. Okay, so that's what matters. In this triangle, these two triangles, we are looking at the fact that we are given information about angles and sides. So in class, we looked at this approach as angle-angle similarity. So we used our triangle angle sum theorem to find that I do have a second pair of congruent angles. The first pair was marked 56.5. We found this one to be 101.2 by using that triangle angle sum theorem. But, maybe I don't see all those angles, but I do see the fact that I have a shorter side and a longer side, a shorter side and a longer side. So I could compare 6 to 4 and 12 to 8 and get this same conclusion with a different reason. I could use side angle side similarity on this problem as well. And that's why it's important for you to share your evidence with me so I know what thought process you're using. Okay? Because if you approach from side angle side similarity, that is a much different approach from angle angle similarity, but we can make the same conclusion. Okay? So I just want you to be aware of that process. All right? Lastly, we took a look at an example on the next page. All right? Where again, we were given information about one set of angles, and we have information about all three sets of sides. So in class, classmates worked together to get us in the direction of side angle side similarity. You found those congruent angles right away, which was awesome. And then we compared the lengths of the sides that form that angle. We could also approach this through side-side-side similarity. So I could, again, compare. We did big over small, so I could compare 736.4 over 315.6 to see if we get that same ratio of 2.3 repeating. So you're going to grab your calculator and do 736.4 divided by 315.6, and it also is 2.3 repeating. Okay? So I could use side-side-side similarity as well. So we have multiple approaches, multiple logical paths we can follow. We just have to come to that same conclusion of our triangles being similar. Okay? That was our conversation in class today for November 19th. Thank you very much, and I will see you later.